this topic. So in last lecture we have started with matrices and arithmetics operations that you can perform on the matrices. So last lecture we have defined a matrix as a two-dimensional array. So when you want to define a matrix of size n rows and m columns, then what you can do in Python is you can define a two-dimensional array of n rows and m number of columns. Okay. So hence, from now onwards, if someone asks you, or if the question is given to you to define a matrix with n number of rows and m number of columns, then in Python, you will create such a matrix by using 2D array declaration. So in 2D array, you can have first is number of rows and second dimension as a number of columns. And we have seen various ways how to declare a 2D array. So whichever is suitable or you find it a convenient to use, you can use that way to define a matrix of a two-dimensional array. So after that, we have started with some basic arithmetics on matrix operations as a matrix operation. So in yesterday's class, we have seen addition of two matrices, and we came to know that the two matrices are added element wise. Okay, and we have understood the concept of elementary operation. Whenever we say some operation between the matrices is elementary operation or performed element wise, then in that case the respective position elements will be selected to do the or to apply the arithmetic operation. If it's addition, then respective position elements are added. If it's a subtraction, then respective position elements are subtracted. If it's a division, then respective position elements are divided. And for multiplication, in the last lecture we have seen there are two types of multiplication operations you can perform on the matrices. One is elementary wise matrix multiplication, which is also called as a hard-marked matrix multiplication, wherein the respective position matrix element are multiplied with each other and we get the resultant matrix. In all the operations where the arithmetic operation is elementary wise, then in that case the mandatory condition will be to have both the matrices on which we are applying arithmetic operation must be of exactly same size. So this part we have concluded in the last lecture, and you can make a note of it that whenever you perform an elementary operation, that is element wise arithmetic operation on the respective position of the element, then it is mandatory that both the matrices must be of same size, because when we are performing an element wise operation, then each element of respective position must be matched with, or what we can say is there must be a element present at the same respective position on another matrix. Okay, if the matrices differs in the size, then elementary wise operation won't be performed, right? After that, we have started and we have seen a short example of row column wise operations for matrix multiplication. Okay, and that is also called as a dot product. In case of like and linear algebra, when I say it's a dot product, then we had already defined a dot product on a vector in earlier lectures, and then in yesterday's lecture we are saying dot product on 2D array. Okay, so what we can say in this case, the dot product applied on two-dimensional array is exactly same or gives the same result as row column wise matrix multiplication. That is when we do first row first column operation. This is little bit different than our elementary wise operation, And what do we expect over here? We expect over here the two parameters, that is the dimension of a matrices may not be exactly equal, but number of columns of this first matrix must be equal to the number of rows of the second matrix. Okay, this is the mandatory condition when you want to apply a dot product, right? So in yesterday's class, we have defined these two rules on the matrix multiplication and in general the arithmetics of a matrices. Number one says that when it's an elementary operation, then order of matrix must be exactly same. Must be exactly same. Right? However, if it's a row column matrix multiplication, then in that case, or we can say if it's a dot product between the two matrices, then in that case, the number of columns of first matrix must be equal to number of rows of the second matrix, right? And the resultant matrix will have the dimension, that is number of rows from first matrix and number of columns from the second matrix. We have also seen an example on it, and we can quickly revise that example. We had taken one array A with 3 rows and 2 columns. We have displayed the matrix A. Then we consider matrix B with different dimension, that is 2 rows and 2 columns. So here one thing can be concluded is like an element wise operation, wherein number of rows, number dimensions of the first matrix exactly equals to dimension of second matrix is not the requirement in case of a dot product. However, only one requirement, number of columns. See, how many number of columns are there? 2 columns, 1 and 2 must be equals to number of rows. How many rows are there? 2 rows, right? And hence we satisfied this first rule of row column matrix multiplication, or the rule of format the matrix dot product. Okay? And if this has been satisfied, you can go ahead and multiply these two matrices. So this is matrix B has been displayed here, and then he applied dot product exactly the same way we applied dot product on two vectors. That is, first parameter is the first matrix multiplied by, or I can say, a dot product with second matrix, that is B, right? And then we displayed the result of matrix C. So I'll execute this instruction. I can see in the result, this is matrix A, matrix B, and the output matrix C. As we recalled in the yesterday's lecture about the dot product applies like this: first row, first column. Okay, that means 1 multiplied by 1 plus 2 multiplied by 3. So 6 plus 1 is 7, and so on, right? Second rule I want to tell you here for this row column matrix multiplication or the dot product of a matrix. So the first rule we have defined is number of columns of first matrix. That means, say if it is denoted as C1, must be equal to number of rows of second matrix. That means R2. Now second rule is when you multiply matrix A, when you say matrix A multiplied by matrix B, right? It is not equal to, or I can say is different from matrix B multiplied by matrix A. Okay. See this, both the operations are different. See matrix A, we are multiplying with matrix B. Now we will see the example. Consider in this example. Okay. This is matrix A, and what I can do here, I'll print size of matrix A. And how you will print the size of matrix A? It is matrix name dot shape. Okay. Similarly, we will print here the matrix B, shape of matrix B, and similarly we will print here the shape of matrix C. Now we can observe here the matrix A is 3 rows and 2 columns. Okay, and the size of matrix B is 2 rows and 2 columns. According to our rule, matrix C, that is resultant matrix, will have 3 rows and 2 columns. Okay. Now, if I do a different, or if I try to perform a different operation, that is, if I try to perform this operation, observe here, that is matrix B multiplied by matrix A. Okay. Now the size of matrix A and size of matrix B is known to you. And I want to perform this operation, matrix B multiplied by matrix A. Here in the example above, we performed A multiplied by B. Now I'll go and see the two rules which we have defined. See, both the results are different, and this is the first rule or the criteria, it must be satisfied. Now you will answer me this question. Will I get a correct answer, or will I be able to execute this instruction if I perform B multiplied by A? And if I'm not able to perform, what is the reason? Okay. I'll repeat the question. You have to answer. All the students will respond to this question, whether we'll be able to perform this matrix B multiplied by A or not. And if we are not able to perform this matrix multiplication, what is the reason? Okay. Okay, so many students have given a very correct answer, but only 2-3 students I can observe here. Like I don't know what's the confusion again they have, and we'll see it. So this is the rule number 1. According to rule number 1, it says that the number of columns of first matrix equal to the number of columns of a second matrix. Now, which is my first matrix in this multiplication? Okay. So I'll take this with the examples down here in the explanation. So this is my operation number 1. So I can say here we performed A multiplied by B. And second, it says B multiplied by. Now we can observe here, in case of this, the first matrix was, okay, in case of this example, first matrix is A and second is B. However, in the second example, if you carefully notice how it has been framed or how we have tried to perform the operation, according to this, the first matrix given this dot product. Okay. First matrix which we have given to the dot product is matrix B, and second matrix is what? Is matrix A. Right? So this is an operator, you can say. This dot function, consider it as an operator, and it has two operands or parameters is A and B. We have defined the second rule, which says that the order of a matrix which is being given in this multiplication operator will differentiate in the result. If we supply A first and B then, and then in second example, if we apply like matrix B first and then A, then you will get both the results different. So you can observe here what we have performed, or what we try to perform is, in case of first, A was the first matrix with size 3 rows and 2 columns, and B matrix with size 2 rows and 2 columns. If I try to extract the C1 parameter, that is C1 indicates the column of first matrix. So this is my first matrix and columns are 2. So I can say the value of C1 is 2, right? Comma equal to the number of rows of the second matrix. So this is my second matrix and R2 is nothing but this first parameter. So R2 is equals to 2. So this particular first operation has satisfied this rule. Now if you check in the second operation which we tried to perform, the first matrix is B, and hence according to rule, number of columns of the first matrix. So the matrix B is of size 2 rows and 2 columns, and matrix A has size 3 rows and 2 columns. According to this, my C1 has value in this example, right? For operation number 2, or for the second example, this is B is my first matrix, and according to this, its number of rows are 2 and number of columns are 2. So C1 will have value here 2. Comma, I'll say it must be equal to the number of rows from the second matrix. For this example, the second matrix is B. Second matrix is A. Okay. So B is the first matrix and A is the second matrix. So in second matrix, the number of rows are 3. So I have R2 equals to 3. Okay. And what our rule says C1 must be equals to R2. So you can check now whether this condition is satisfied by the first operation. Yes, it is satisfied, and hence we got the correct result of matrix multiplication. But in the second operation, this rule is not satisfied. Okay? So when you change the order of matrix multiplication, that is, if we change which is the first matrix in operation and which is the second matrix, it will change the result, and sometimes it will not satisfy this condition and may not be able to perform the matrix multiplication in reverse order. Okay, that is A multiplied B may be possible in some cases, and in some cases B multiplied by A is not possible. And this is the example wherein it demonstrates that if you multiply A with B, then you can find the answer of multiplication But if you try to multiply B with A, it is not possible because it violates the rule of this matrix dot product, that is number of columns for first matrix must be equal to number of rows of second matrix. I hope those who have this doubt has been clear. Okay, so Ashish Raj is there or some other students are there, okay, who have been said that it is possible. So please note it down somewhere properly that why we can't able to perform this matrix multiplication. Now what we can do is we will execute this instruction and we will try to see what Python will do with this. Okay. So what Python is saying, it says a value error, right? And this is a description of a value error which describes that the shape 2, 2 of first matrix B and the shape of second matrix, that is 3, 2 is not aligned. Okay, which says that the dimension 1, that means according to this dimensions, what it says, it is dimension 0 and it is dimension 1. Okay, there are two dimensions and matrix in case of Python, indexing always start with 0, and hence as there are two dimensions, the dimension first dimension is the dimension 0 position and the second dimension is at the first position. Okay, so what Python is trying to say is the first dimension, that is number of columns, is not equal to the 3, that is dimension 0 position. Okay, so and hence in this example it is not able to perform. Now why we know that we cannot perform these operations and still be executed here, because I just want to demonstrate in front of you that in future, if you end up by doing a matrix multiplication which doesn't satisfy the rule number 1 and you got this error, then you must be able to understand what is this error mean. Okay, so when you in future, whenever you try to multiply the two matrices or whenever you try to perform dot product between the two matrices and you get an error like this, then you must understand that that is the rule number 1, that is number of columns of first matrix is not equal to the number of rows of the second matrix. And you can go back and check and correct your matrix order of multiplication, right? And yes, I'll expect that after this, if such error occurs, you must be able to resolve this error. You must be able to solve this error. Okay, so there is one question from Atharva. He says, if we have a matrix A and matrix B of some size, then will it be possible to multiply this matrices? So I will open this question to all the students to answer, and I hope that every student will be able to answer now. If the matrix A is of order 3 cross 2 and matrix B is of order 2 cross 3, okay, then can we multiply these two matrices? Okay, I want every one of you to answer to this question. Manoj is saying no. Pankaj Sharma, why you are no? Abhishek Singh. Okay. So yes, we can multiply these two matrices. Now we will see according to our rule. What do you want to perform? You want to perform C is equals to matrix A multiplied by matrix B. Okay. So which is my first matrix? First matrix is A. And the dimension R, R1 number of rows equals to 3 and number of columns is equals to 2. Comma, second matrix is B. Dimension, number of rows equal to 2 and number of columns equals to 3. What is your rule? Rule says number of columns of a first matrix equal to number of rows of second matrix. So check this parameter. What is value of C1? It is 2. Whether it is equals to, what is the value of R2? 2. So it satisfies the condition, and hence it is possible to multiply a matrix of this size. And what will be the result? Resultant matrix C will have a size of matrix C. What is the size of matrix C then? If you multiply 3 rows 2 columns and 2 rows 3 columns, then this middle dimension gets vanished and we have a matrix C with dimension 3 rows and 3 columns. So now I'll start with some another examples. Okay. Now we have seen this matrix multiplication by using a function dot, and there is another operator available which we can use to perform this similar operation. I'll again repeat. Python has another operator which can do an exactly same operation, and that operator is called as an @ Okay, so I have written over here. You can check it. C is equals to matrix A @ okay, matrix B. So this is an @ symbol which you used in the email. Okay. So this, what this operator will do? This operator is defined in Python library, which performs what? Dot product, or which perform row column matrix multiplication. Right? I have taken the matrix A and B from the same example, that is matrix A and matrix B, and this is what matrix C is. So what I will do is I'll print again these two statements for you to understand this example. So before performing an operation, I'll print matrix A, I'll print matrix B, okay, and then we'll print matrix C. So you can observe here what we have done is we have first displayed the matrix A with its size, then matrix B with its size, then we have applied this operation. All of you please note it down, this operation. It's very easy to remember when you want to perform dot product of a matrix. Then you can use this @ symbol and then you display the result matrix, that is C. Execute this. So this we have matrix A of size 3×2, matrix B of size 2×2, and the matrix C we have. Okay, so we got the same result as we have done with the dot product. So I hope this is clear, and then now we will move ahead and we'll see. So this kind of operation was matrix multiplication. So in this example, we have done, or we executed one matrix to multiply with another matrix. We'll see next example wherein we try to multiply a matrix with a vector. Okay. So if I want to say this operation in terms of a Python, okay, if it's in a linear algebra, we want to say that we want to multiply a matrix with a vector. So what exactly we are multiplying in the linear algebra? In terms of a linear algebra, what we will going to multiply? What we are going to multiply is, we are going to multiply, what is a matrix in linear algebra? Matrix in linear algebra is a 2D array. Okay. This 2D array we will try to multiply with a vector. What is a vector in Python? It's a 1D array. So when I say in linear algebra, I want to multiply a matrix with a vector, then what exactly I am going to do? I am going to multiply a two-dimensional array with a one-dimensional array. Okay. So now, whenever we want to multiply matrix with a vector, you will have to always have some rules on shape of this 2D array and on shape of the 1D array. Okay. As we have seen this rule being applied to elementary multiplication as well as the dot product between the two matrices, you will also have to satisfy one rule when you try to multiply a matrix with a vector. And what that rule is exactly, we'll explore it through an example. So see, this is an example where we have defined one matrix. So we can identify here A is a matrix because it has the number of rows defined. And how many number of rows are there? 1, 2, and 3. Okay. There are three rows defined here. And how many number of columns we have? Number 1 and number 2. Right? So I'll just display for your understanding, that is shape of this matrix A. Okay. So we have a matrix A of size 3 rows and 2 columns. We will now have a 1D array, that is a vector. Okay. And how we define a 1D array? By using a single opening and closing square brackets. So what I have is A is equals to an array with only one dimension. That is, the number of elements are 2. Okay. So first element and second element. I'll print A, and what I'll do here, I will also print the shape of this 1D array. Okay. Right. So from so many examples which we have taken on 1D and 2D array, we always try to print the shape of an array as well as the dimension of an array. Now I expect that all students can understand the difference between the shape of an array and dimension of an array. Okay. Dimension of an array indicates that how many dimensions an array will have. Whether it have a single dimension, which simply counts the number of elements, or whether it have 2 dimensions, which says the number of rows and number of columns. Okay. When you print ND parameter for an array, it will tell a scalar value, that is whether the dimension is 1, whether the dimension is 2, whether the dimension is 3, and so on. However, if you try to print the shape of a matrix, in case of a shape of a matrix, it will tell you how many values individual dimension will have. Okay. So the shape of a 2D array will tell how many number of rows and how many number of columns. And the shape of a 1D array tells how many number of elements are there in the first dimension. Okay? And second dimension 1D array don't have. Second, third, and fourth, and so on. So there is only one dimension. Okay. So here we have displayed the shape of both the arrays and we have printed that respective array also. Now what I'm going to do is I'm going to perform a dot product, or we can say the multiplication between a matrix and 1D vector. We'll have to again notice here what is being supplied to this dot product and in what sequence. Okay. I'll repeat here. You have to note down from this particular instruction what parameters or what values we are supplied to dot product and in what sequence. So you can observe here we have given a 2D array and a 1D array. Okay. Second observation says that first parameter is my two-dimensional array and the second parameter is 1D array. Okay. So as per the rule, I can say that there are okay. So as per the rule, what we can see here, you can multiply this array, that is for first operand, okay, is matrix A with dimension, or you can say with size 3 rows and 2 columns, comma second operand is vector E with size, the size of this vector is 2 elements. Okay. And we can do this because the second parameter is matching with the first parameter. Okay. I repeat this, we are able to perform this operation because this second parameter is matching with this first parameter. However, vector don't have a second parameter. Okay. And hence we don't need to bother about what the second parameter is. And we will execute this result and we'll try to see what you will get in the answer. So we have first is matrix A and its shape is 3 rows 2 columns. Then we have matrix B and what we have in the matrix C. Okay. Now 2-3 things we have to note down here. I'll print matrix C dot, C is a capital, matrix C dot shape. Okay. So when we multiply a 2D array with 1D vector, then what you will get in the result? You will get in the result a 1D vector and is of size 3 elements. And how the multiplication is performed? You see, first row and it is considered as multiplied with this first 2 elements. That is 1 multiplied by 0.5 plus 2 multiplied by 0.5. Okay, this first row is multiplied by this first two elements. So 1 multiplied by zero point 0.5 is 0.5 plus 2 multiplied by 0.5 is 1.0. 1.0 plus 0.5 is 1.5. Similarly, this second row multiplied with these two elements and you got this result. Third row multiplied with this two elements and you got this result. Right? And I have told you, and you can again note down, in case of this, I'm again telling this two operation. Huh? And please note down, and you don't have, should not have this question again. This operation is exactly equal to this operation. There is no difference in it. And we demonstrated through example. Okay. So what you have is exactly same. There is no difference in this two. This is the only two different way Python provides. Okay. There is simply two different ways Python provides to apply this dot product. Nothing is different in first and second operation. You will get exactly the same result. And this is what you will get when you multiply a 2D array with a 1D array. Okay. So now I'll have an example for you. You try to do it and you tell me what you get in the result. So operation number 1 is matrix A is equals to array okay, comma B is equals to array and perform operation C is equals to, right? This is first. Second is consider x is equals to okay, consider those two examples and try to solve this. Solve these two examples and tell me what you get. Wait for it. You have to solve these two questions together and you have to answer me in the one go, that is in the one comment. What is the answer of question number 1 and what will be the answer for question number 2? Right. So many questions, many students have given the answer, and we will see here in this example number 1 what is going to happen. Okay. So you can observe here what is the dimension of matrix A given here. Matrix A is of dimension 3 rows and 3 columns. Okay. Matrix A have a dimension 3 rows and 3 columns. And vector B have 3 elements. Matrix B have 3 elements. So when you multiply A with B, you will get the value. That means the first row is multiplied with these 3 elements in the respective position. Okay, right? So okay, I understood that everybody of you are getting a correct answer and you are giving me a very that's very good. But just now see here and see through this example what actually is going to happen. Okay, so we will see how it is multiplied. So now observe this first row. It gets multiplied with corresponding position elements of matrix, this vector B. That is what will happen is 1 multiplied by 1 plus 2 multiplied by 1 plus 3 multiplied by 1. And hence in C you will get the first element. What is the first element you will get? 1 into 1 plus 2 into 1 plus 3 into 1. That is 3 plus 2 plus 1 is what? 6. Comma. Okay. What will be the second element? That means you will get to have second row is multiplied with this particular elements from vector B. So 1 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 1. Okay. So what you will have? 1 plus 1 is 3. And what will be the third element in matrix in vector C? You will have this third row of matrix A multiplied with the elements of vector. So we will have 2 into 1 plus 2 into 1 plus 2 into 1. That means 2 plus 2 plus 2 is 6. This is what you will get in the result when you multiply or when you perform the first operation. Okay. Now we will see the second operation. Observe over here what we are trying to do. We are trying to multiply this 2D array X with a vector Y. What is the dimension of this particular 2D array? It has 3 rows and 2 columns. But in vector Y, we have 3 elements. And how we perform the operation of multiplication, that means a row of matrix X is multiplied with corresponding elements of vector Y. So when you consider to multiply the first row with this element, what will happen is, let's see now, 1 is multiplied with 1, 1 is multiplied with 2, and there is no further element to multiply with 3. Okay? So it means that the number of columns, that is the second parameter of matrix X, is not matching with number of elements with present in the vector, right? And hence this type of multiplication is not possible, right? So we will execute these 2 examples on Python and we will see what is the result. So we have this array A. What we do is we will print matrix A. Then we will have this vector A and we print perform this operation and then we'll print okay. You see here matrix A is displayed. Then vector B is displayed. Uh, and then we have a result 6 3 6, and then we'll try to perform the second operation. Okay. So we will print matrix X is displayed, vector Y is displayed, but we cannot perform this operation. And what is the error? It say input operand 1 has a mismatch in its core dimension 0. Okay. So what we can say, this n into k and k into m is not matching. Okay. So size 3 is different from 2. That means size 3 number of columns in first matrix has 3 elements. However, there are only 2 elements in the vector. Okay. So it has 3 elements in the column and 2 elements in the number of rows and 3 elements in the vector. Okay. So it's not possible to multiply. Right. So I hope this is clear. Otherwise, asking a question, then 1D vectors multiplication possible? Yes, possible. We have done that. Okay, Atharva. And I think day before yesterday, our topic was a vector. And in that case, we have explored all operation on the vectors. In today's class, we are seeing matrix arithmetics. And if you go back and see the last 2 lectures, then you can see there is a topic called vector arithmetics. Under vector arithmetics, we have seen various types of multiplication between the 2 vectors, or with various types of arithmetic operations to be performed on 2 vectors. Now we will go ahead and we'll see the next topic, that is a matrix scalar multiplication. Okay. So you can see here what we have seen in the first case is matrix vector multiplication, and the earlier is matrix multiplication. Okay. So one matrix is multiplied with second matrix, right? And here, second example, we have seen how to multiply matrix with a vector. And now third case of multiplication is matrix and scalar multiplication. Okay. So you can note down, number 1 operation is matrix multiplied with another matrix. Number 2 is a matrix multiplied with a vector. And number 3rd operation we are going to see in the multiplication of a matrices is a matrix is multiplied with a scalar value. Okay. So under matrix multiplication, two operations we have already seen. The first operation we have seen matrix multiplication using dot product and by using elementary operation. Then we have seen matrix and vector multiplication. And now we are going to see matrix and scalar multiplication. Okay. So now, can anyone tell me what is a scalar means? Because we have seen this term in the last 2-3 lectures. Okay. That is in case of a vector multiplied with a scalar. That's very good, Nidhi. She has given a very good answer in terms of a Python, that is a zero-dimensional array. Okay. So 0D array or a single value or a single number is nothing but a scalar value. Okay. That's really very good. In terms of a Python, you can say 0D array, zero-dimensional array is nothing but a scalar value. Okay. Or a single element even can be a scalar value. So what we are going to do, it's been very clear to all of you now then, what we are going to multiply. Okay. So I will have in this example a matrix A defined, right? So how many rows matrix have? Row number 1, row number 2 and row number 3. So this matrix A have a dimension 3 rows and 2 columns. Now we have defined a scalar value. You can define a scalar value in a two way. One is by using directly a variable is equals to a value, or like we have seen a 0D array, and both have the same meaning. Okay, I'll repeat here. There are multiple ways for a declaration. Okay, so one way is directly assign a single value to a variable which will be representing a scalar. Or second is we can use a 0D array declaration. That will again be a scalar value. Right? So we have used here a very simple way, that is b is equals to 0.5. So I will write here before printing that what we are printing, a message, that is matrix A. Similarly, before printing B, I'll write here print scalar value then we are going to multiply. See here, now everybody will tell me the answer. What is this star? Which type of multiplication star will do? Elementary. Suruchi has answered is elementary is exactly correct. Okay. So if you catch this type of representation, what does they mean? Then 90% of the task is already done. Okay. By operator itself, if you identify that what kind of operation that operator will do, then 90% of the understanding has been cleared that what we are trying to perform or what type of multiplication we are trying to perform between a matrix and a scalar. Okay. So under multiplication, we have seen 3 different types. One is the element wise or elementary multiplication. Second one is row column multiplication by using dot function. And third one is again row column multiplication by using @ operator. Okay. Here we have used star, that is asterisk operator, which says that it's a elementary operation. In case of elementary operation, this scalar b will be multiplied with a element wise. Okay. And this kind of operation is also called as, can anyone tell me what we call this kind of operation? If you recall from a vector, it is also called as scalar broadcasting. Okay, remember this term, broadcasting. That means this B will be multiplied with every element in A. Okay? In broadcasting, zero point 0.5 will be broadcasted and type of operation performed here will be multiplication to every element of A. So will there be any rule of for dimension of A and dimension of B? No, there won't be any rule and there won't be any requirement of any rule, because this scalar B will be applied for every element, right? As scalar B will be applied to every element individually, right? So we'll see what we expect in C then. 0.5 multiplied by 1, that is 0.5. Then 0.5 multiplied by 2, that means 1.0, and so on. Ashish has given an answer, but Ashish, this is not the way we multiply. In case of a scalar, it's a scalar multiplication, it's a broadcasting. That means there won't be an addition performed like a dot product. Okay, A is not a, like here B is a scalar value. Scalar means single value. Okay, when you multiply 1 with 0.5, it will just multiply, it will just go and multiply and remain that value only at that position. I'll execute it and we'll try to understand. So this is matrix A. This is scalar value B. And I'll write here print so what will happen here, just concentrate. When you consider the first row for multiplying, okay, when you consider first row, okay, now listen here, actually you are confusing between one dimensional vector multiplication and scalar multiplication. Okay, so don't do that confusion. Now listen here. When you consider the first row for a multiplication, it will consider individual element. Okay, so 0.5 is multiplied with point A, that is 1. This is a one single operation. Second operation will be 2 multiplied with 0.5. So you will have the first row as it is, and you have 1 multiplied by 0.5 is 0.5. 2 multiplied by 0.5 is 1.0. Similarly, for the second row, 0.5 will be multiplied with individual element. What I said is elementary operation, how it is different? In case of an elementary operation, this element scalar value will go and multiply individually, element wise, okay? Not together, element wise, okay? Separately. Every element will have its own result. They will not combine, they will not get added. Okay, like in the 1D vector. This is a scalar multiplication. So Ashish and Yash, remember that here we are going to perform a scalar multiplication. So every individual element, and it's also called as an elementary operation or element wise operation, because every element gets multiplied by this scalar value. Okay. So A is what? 0.5 times the A will be represented actually only. That means every element of this two-dimensional array A is been multiplied individually, element-wise, by a scalar value 0.5. Okay. So how it is? 1 multiplied individually with 0.5 and we will have the result 0.5. 2 multiplied by element-wise with 0.5 and you will have 1.0. Similarly, 3 multiplied by 0.5 is 1.5. 4 multiplied by 0.5 is the 2.0. 5 multiplied by 0.5 is 2.5. And 6 multiplied by 0.5 is 3.0. Okay. And this is what do we mean is an elementary or element-wise operation. Okay. That means this kind of operation, whether it's a multiplication, addition, subtraction, division, will be performed element wise. And you can have such a different arithmetic applied by using a scalar value, right? And you will have multiplication of this scalar before and after the same effect. What do I mean to say that? In earlier example, matrix A was multiplied with B and it will have exactly same meaning when you try to perform B multiplied by A. The meaning is same, meaning is exactly same. You can see it from an example execution, that is, this is A, this is B, and this is, you will have C, exactly same, 0.51, 1.52, 2.53. So whether the scalar is multiplied before matrix or after matrix, it won't change, because what is going to happen? This element is going to individually be multiplied with every element, and that element wise operation we also call it as a broadcasting. Okay. So now if you take another example, say x is equals to array so in array I have first value, second row, third row, okay, and I'll print it array x. Then I will have a scalar value, that is small y is equals to, you can take some scalar value, say for example it is 5, right? And we will go on printing this scalar element small y and then you will perform this broadcasting of y to array x as, so you can perform it any way. So x star y, x is capital we define here, so you have to take capital X, and then you will print result in z print z. So we have matrix X here with elements 1, 2, 3 in each row, and we want to multiply it with 5. So you can see the result is 1 multiplied by 5, 1 multiplied by 5, 1 multiplied by 5. Similarly, for second row, it is 2 into 5 is 10, 10, 10. And similarly, 5 gets multiplied with each element in the third row. So it is 15, 15, 15, right? I hope it is clear to you. That is number 1, when you multiply a matrix with another matrix. Number 2, when you multiply a matrix with a vector. And number 3, when you multiply a matrix with a scalar value. Okay. So I hope this is clear to you all. And now if we have any doubts on this particular topic, then you can comment in the chat window. Otherwise, we will start with next topic. Before starting next topic, I want to close this topic of matrix arithmetics. So if you have any doubts related to matrix arithmetic, you can go ahead and type your question in the chat window. We will take those questions first and then we will start the next topic.